Hi everyone, welcome back to the Coding Interview Must Know series. Today we're looking at a classic matrix problem, the spiral matrix. The idea is simple. You're given an m by n matrix, and you need to print out all its elements in a clockwise spiral order. For example, take this 3 by 3 matrix. In spiral order, the output is 1, 2, 3, 6, 9, 8, 7, 4, and 5. Here's another example, a 3 by 4 matrix. Its spiral order follows the path shown in the animation. The best way to solve this problem is the boundary shrink method. We keep track of 4 boundaries: top, bottom, left, and right. Each round, we walk in a clockwise direction, first along the top row, then the right column, then the bottom row, and finally the left column. After finishing each side, we shrink that boundary inward. We repeat this process until all elements have been visited. Let's walk through this using a 5 by 5 matrix and some Python code. First, we set 4 variables: top, bottom, left, and right. They represent the 4 boundaries of the current layer. As long as top is less than or equal to bottom and left is less than or equal to right, we traverse the matrix in the order top, right, bottom, left. After finishing each side, we move the corresponding boundary inward. Let's break it down step by step. First, traverse the top row, then increase top by 1. Next, traverse the right column, then decrease right by 1. Then, traverse the bottom row and decrease bottom by 1. Finally, traverse the left column and increase left by 1. After shrinking all 4 boundaries, we move on to the inner 3 by 3 matrix and repeat the same process. We traverse 3 elements on the top, 2 on the right, 2 on the bottom, 1 on the left, and finally visit the center element, 13. This completes the entire spiral. There's one important detail in the code. Before traversing the bottom row or the left column, we must check whether top is still less than or equal to bottom, and whether left is still less than or equal to right. Why? Because after finishing the top row and right column, it's possible that all rows or all columns have already been consumed. Without this check, in cases like a single row or single column matrix, we would end up visiting elements twice. This algorithm runs in O of m times n because each element is visited exactly once, and it uses O of 1 extra space aside from the output list.